Today's lesson is solving systems using elimination by multiplying. And this is lesson 37. In lesson 36, you'll recall that we solved systems using elimination by either adding or subtracting. In this lesson, we're going to add in one extra step in which we have to multiply, and you'll see what I mean as we go through these examples. Before we begin, I just want to show you that the skill you're going to learn is a combination of two skills you already know, one being the one that we learned in lesson 35, which was just simple elimination, where we added or subtracted the equations to eliminate one of the variables, and then we're going to use some scalar multiplication, or I guess you could think about this as some distribution. So let's just go through these old examples real quick so we're familiar with what we're doing. So in this first example, we have 3x minus y equals 3, and we had negative 3x minus 2y equals a negative 3, and we're solving using simple elimination. So essentially, we're looking at the two variables to see if which one has opposite numbers in front as coefficients. So the x variable here has a 3, and it has a negative 3. So when we add these together, 3 plus a negative 3 simplifies to 0, and 0x is just 0, so that variable has been eliminated. So we're going to go ahead and add the equations together. 3 plus a negative 3 is 0x, and then negative y, which is the same thing as negative 1y plus negative 2y is a negative 3y, and then 3 plus a negative 3 is 0. 0x is just 0, which we know because that variable has been eliminated, and now we can just solve for the remaining variable. We're going to divide by the number that's being multiplied to y using inverse operations, and y equals 0 divided by negative 3 is just 0. Then our last step to complete the system was to find the x value, because we know the y value is 0. We would take the value for y and substitute it into the y variable in either equation. In this case, I'm going to choose the top equation. So I have 3x minus 0 for y equals 3. So essentially we just have 3x equals 3, and then we can solve for x by dividing by the number it's being multiplied to it, and x equals 1. So there is the first example. The second example that's going to help us today is scalar multiplication or distribution. Again, if you don't remember what we did, we were given a matrice, and then we had this number outside, and if you replace this bracket with a parentheses, you can see that this 2 is could be distributed, right? And that's exactly what we're going to do. We're going to distribute the 2 or multiply it to all the values inside the brackets, and we get 2 times negative 5 is negative 10, 2 times negative 3 is negative 6, and 2 times negative 5 again is negative 10. Fairly easy there. So what we're going to do is we're going to take simple elimination and throw in some multiplication. So here's example 1. For this first example, as I go through the steps, make sure you are filling in the words. For the second example, you will fill in the equations, not the words. And then the third example, you'll try on your own. So the system is 2x plus 6y equals 6, and the second equation in the system is 3x plus 12y equals 15. And again, we're trying to find where these two lines would intersect if we were to graph them. So if you look at the equations right now, you can see that there are no opposite numbers in front of the variable. So we have 2 and 3, those are not opposites. 6 and 12 are not opposites. So what we're going to have to do is eventually create the opposites by multiplying. So our first step right up here is to look for the variable that has a factor, meaning a number that can divide into the coefficient of the variable in the other equation. So does 2 divide into 3 evenly? No, it is not. So 2 is not a factor of 3. Does 3 divide into 2 evenly? No, it does not. 3 is not a factor of 2. Okay. Does 12 divide into 6 evenly? No, it doesn't go into 6 at all. Does 6 go into 12 evenly? It does. It goes into 12 2 times. So 6 is a factor of 12. So we've identified that this equation has a coefficient that is a factor. And now our second step is to scalar multiply this equation by a number that's going to create the opposite of 12. So what's the opposite of a positive 12? Well, it's a negative 12. So what number do we have to multiply this equation by to get a negative 12 in front of the y? Well, 6 times 2 is 12. But that would give us a positive number. We need it to be opposite. We need it to be negative, so we're going to multiply by negative 2. And now we're going to scalar multiply the entire equation, or distribute this negative 2 to all three terms. And what we get is this resulting equation I'm going to write right here, which is negative 4x. Negative 2 times 6 is a negative 12. There's our opposite numbers. Equals negative 2 times 6 is a negative 12. And it's really easy to forget to multiply this last term. So make sure that you're multiplying it to all three. Now, if you can see, we've got opposite numbers in front of our y variable. So when we add, it's going to create a 0 in front of the y, which means y has been eliminated. So let's go ahead and do that now, which is our third step. Add to eliminate one of the variables. 3 plus a negative 4 is a negative 1x. 12 plus a negative 12 is plus 0y. And then 15 plus a negative 12 is the same thing as just 15 minus 12, which is just 3. So here we have our y variable, which has been eliminated, and now we just have negative 1x equals 3. We can go ahead and solve for x by dividing by negative 1, divide by negative 1, and x equals a negative 3. So we now know what x equals, so we can go ahead and move into the fifth step, which is to take this value for x and substitute it in for x in one of the two equations. I'm going to substitute it into the first equation, so I'm going to take this negative 3 and I'm going to put it in here for x, and what I would get is 2 times negative 3 plus 6y equals 6. 2 times negative 3 is negative 6. And now we can go ahead and solve for y. So we're going to add negative 6 to both sides. We're going to add 6 to both sides, sorry. These go to 0, they're gone. So we have 6y equals 12. And now what we can do is just go ahead and divide by 6. Divide by 6. And what we get is y equals 12 divided by 6 is 2. So we now know what the point of intersection is. The point is negative 3 for x and 2 for y. And I would type in negative 3 for x and 2 for y. Okay, example number 2. So as I go through this example, I do not want you to fill in the words because we've done that in example 1. Now I want you to fill in the equations, and I'll draw arrows at the equations that I want you to type into your notes. So here we have negative, and here's the first equation, negative 12x minus 4y equals a negative 8. And then the second equation I want you to draw is, or type in, sorry, is 6x minus 6y equals 12. So look at the two equations and think back to the previous example where we had the steps written out. We wanted to identify the coefficient that is a factor of its counterpart. So is 6 a factor of negative 12? Well, 6 is a factor of negative 12, so that was fairly easy. So we know that 6 here is the factor. So what we have to do is we're going to multiply this equation by what number to create the opposite of a negative 12? Well, the opposite of a negative 12 is a positive 12, so we're going to multiply this bottom equation by 2. That way there's a positive 12 in front of the x. So go ahead and scalar multiply this entire equation. We're going to multiply 2 to every single term. And now I want you to write this resulting equation or type it into your notes. So 2 times 6 is 12x. 2 times negative 6 is negative 12y. And then 2 times 12 is 24. And actually it's a negative 24, so make sure this was a negative 12. I didn't write it correctly when I rewrote it. So negative 24, right? And now I'm just going to add the two together. So here we have our top equation. I'm just going to write it right here so it's closer. Negative 4y equals negative 8. Okay, and now we're going to go ahead and add them together because we know that the x variable is going to eliminate here. So negative 12 plus 12, we know that goes to 0. Those are gone. Negative 4 plus negative 12 is a negative 16. We're just adding our debt. And then again, we're adding our debt. Negative 8 plus a negative 24 is a negative 32. Now we can go ahead and solve for y. So divide by the number it's being multiplied to both sides. Y equals a negative divided by negative is a positive, and 32 divided by 16 is just 2. Now we can go ahead and move into our last step, which is to take this value for y and substitute it into one of the two equations. So I'm going to substitute it into the bottom equation because that is the one that has the smallest numbers. So here is the equation I want you to type into your notes. 6x minus 6 times, go ahead and use the parentheses for multiplication here, times 2 equals negative 12. And now we can simplify and solve. So negative 6 times 2 is negative 12 equals negative 12. And we can solve for x using inverse operations. So add 12, add 12. These go to 0. These also go to 0. So we have 0 equals 6x divided by 6 just for funsies. X equals 0. So now we have our point of intersection. We're going to go ahead and write it as a coordinate point, 0, 2. Type in 0 for x and 2 for y, and you are done. Use the notes as you go through the problem set. They are what they are. Have a nice day.